Welcome to our open house we prepared for you. This is Materials Science and Nanotechnology program, along with our national lab known as UNAM, which stands for the National Nanotechnology Research Center. We are very excited to host a new group of students at UNAM and offer you a graduate degree both in MS and PhD for Materials Science and Nanotechnology, in short MSN, at Bilkent University. We house one of the most modern research infrastructure in the country, along with major teams available for advanced techniques for processing and processing. Indeed, our teams are very well known for their technical know-how and advanced level of mastering the infrastructure and equipment at UNAM. Here at MSN program, we have been providing a full research environment that includes a great set of instruments along with the professional teams that indeed operate these instruments and provide technical training. And in most of the cases, these trainings become very critical for one's career development as well as personal development. As a matter of fact, at UNAM, thus far, we have granted 578 theses, and most of our alumni thus far have been very successful, spreading across the country and around the globe. Among them, you can find our graduates who have continued their career at top universities worldwide, including Stanford University, MIT, Caltech, Harvard, ETH, Cambridge, and TU Singapore, just to count few. In addition to their academic career, we have also seen our alumni to actually start startup companies. Among them, we have quite successful graduates of whom we are really proud. In addition to academic work and entrepreneurship work, we also encourage strongly our graduates, after receiving their master's degree and PhD degrees, to go into private R&D. This includes indeed both corporates as well as spin-off companies now growing in large quantities in the country and around the world. Our students as well as faculty have indeed acquired a great number of awards. These awards actually count more than 150, but what you'll find interesting is the ratio between the national and international awards is almost 1-to-1. To be exact, we do have 75 international awards received by our students and faculty members, and 76 national awards similarly received by our students and our faculty. The fact that the ratio of the awards, international to national, being 1-to-1 tells us that not only in Turkey, UNAM, along with its MSN program, provides major visibility and presence, but also around the world. UNAM is well recognized along with its alumni, the student body, and the faculty members. Today, you'll be hearing from a number of our faculty members about their research work ongoing in their research programs and in their groups, as well as hear about our infrastructure from our professionals. I am most proud to let you know that the work that has undertaken here at UNAM indeed has contributed close to 300 Nature Index journal publications, which makes UNAM, along with its MSN program, to be #1 in the country. And that indeed has come together with a large number of patent applications. At the moment, we do have over 110 granted patents and larger quantity in the pipeline. MSN program is very carefully designed to include interdisciplinary subjects, and we are very open to students from electrical engineering, from mechanical engineering, from other engineerings, including chemical engineering, textile engineering, and so on, as well as fundamental sciences, for example, from physics, from chemistry, from molecular biology, and genetics. Please do enjoy the open house we prepared for you. Thank you.
Hi, my name is Ayça Arslan Ergül. I am interested in aging in general. Specifically, I'm working on cellular senescence, adult neurogenesis, and brain aging. We mostly use zebrafish as a model organism, but we are obviously interested in human brain aging as well and human neurodegenerative diseases. We published the transcriptomics data from the aging zebrafish brain, as well as effects of caloric restriction in brain aging and neural progenitor cells in the aging brain. As a coordinator, I have been leading transcriptome and evolution project of an endemic fish, the pearl mullet, for 4 years, which has contributors from all over Turkey and from diverse backgrounds. I am also a STEM ambassador and a change maker in Turkey. I gave motivational talks in more than 70 high schools. I have an active YouTube and Instagram accounts. In those accounts, I'm publishing educational content, mostly related to molecular biology. Currently, we work on telomeres in the aging zebrafish model, cell adhesion molecules, and drug-resistant epilepsy. Also, we have upcoming projects in neurodegenerative diseases in human. UNAM provides us a perfect environment to conduct research. Here, the laboratories are open 24/7. The equipment are in common use, and we have freedom in our studies, which is very important in scientific research. People who are hardworking and productive are always highly regarded in UNAM. We are happy here as a group, and if you want to join us, you can visit UNAM's webpage. And also, if you write Ayça Arslan Ergül in Google, you can reach my YouTube and Instagram accounts. Hope to see you in here.
Hello everyone, I am Fatih Engin. I am working as an assistant professor at Bilkent University, UNAM. In our lab, we develop technologies, especially sensor technologies, microfluidic technologies, to address real-world challenges in medicine and biology. In this regard, we manipulate cells in a confined volume of fluids, as well as we develop platform technologies to monitor real-time changes in biological activity, as well as we develop the systems, for instance, biomimetic systems to create the environment that cells and cellular entities or any biological entities can survive. At Bilkent University, UNAM, we do our research, we do our projects at highest levels possible, owing to Bilkent University, UNAM's full-fledged world standard facilities, especially nano facilities, chemistry facilities, and biological facilities.
In our synthetic biosystems laboratory, we are working on developing new generations of synthetic genetic circuits, and we are trying to use the synthetic genetic circuits to develop new processes. Those can be used in biotechnological applications, in biomedical applications, and biomaterials applications. In terms of biotechnological applications, we are mostly focused on developing new biotechnological drug molecules, including biosimilars, but we are trying to develop new processes to ease these systems. And using the ideas from basic science research outputs, we are trying to develop new techniques. Those can be translated in clinic and in real-life applications.
My name is Amir Barami. I have an interdisciplinary background in physics and mechanical engineering. Since January 2021, I have started the new laboratory of living matter and biophysics, the LIMBO lab at UNAM. My research mainly focuses on soft and active matter physics, biological physics, and physics of biomembranes, in particular membrane remodeling in cellular processes. I use a variety of simulation techniques such as Monte Carlo simulations and molecular dynamics simulations, both through in-house developed code as well as computer packages such as GLOMX and LAMMPS, to understand protein-induced cellular and biological processes, to design nanostructures for applications in synthetic biology, and to study self-assembly of nanostructures as well as drug delivery and cellular uptake of nanoparticles. In coming years, I will be leading the first Max Planck partner group in Bilkent, which provides my group with the unique opportunity to connect to the international research community through Max Planck Society in Germany. Specifically, we will have close collaborations with the Department of Living Matter Physics in Max Planck Institute of Dynamics and Self-Organization in Göttingen. In UNAM, we will enjoy collaborating with experimental colleagues, experimental biologists, and through UNAM, 2B Talk and Max Planck Partner Group, we will have access to local, national, and international high-performance computing clusters to perform our simulations.
In our laboratory, we are carrying out transdisciplinary research which intersects the engineering of biomedical devices, sensors, organ-on-chip platforms, micro-nanofluidic devices, and their applications in medicine, pharmaceutical, and bioengineering fields. We are also giving particular focus on the development of innovative and advanced microwave, microfluidics integrated detection and heating platforms, and the development of in vitro microtissue models for nanotechnology-based high-throughput drug discovery and screening.
Hello, I am Bülent Ortaç and I am leading laser research group. In my group, we fabricate novel specialty fibers for nonlinear optics and fiber laser applications. The application change from medical to defense field. We start fabrication process from pure fiber preform using modified chemical vapor deposition system. Recently, we have demonstrated mesh scale 100 kilometers of drawing fibers with our high temperature fiber drawing tower.
I'm Hilmi Volkan Demir. In my research group, we are working on the materials, devices, and systems. Among variety of materials we work on, we have semiconductor nanocrystals. Our work includes the design and synthesis of these semiconductor nanocrystals, their device applications and device engineering, and finally system applications. Indeed, in our group thus far, we published over 300 SCI top-tier journal publications, and among these journal publications, 120 of them belong to the Nature Index family journals. Also, among our publications, we have over 80 journal publications with impact factor about 10 or above. Indeed, graduates of our group have also found great jobs, great positions across the country and worldwide. Among variety of places, they actually were accepted to carry on with their careers after receiving their PhD here include Stanford University, MIT, Harvard University, Caltech, ETH Zurich, and Cambridge University in the UK, as well as NTU in Singapore. We have thus far 16 PhDs graduated from our group at Bilkent University and 19 of them from NTU Singapore, altogether 35 PhDs. Also, in addition to PhD thesis, we have completed in our group thus far 35 master theses. Our group members not only continue their studies and future career in academic world, but they also are quite active actually in high-tech entrepreneurship. And among them, they established several successful companies, which we are really proud of. In our group, we do work on a number of critical scientific questions, including, for example, the high-quality nanocrystals enabled by advanced heterostructures of nanocrystals, the limits of optical gain possible in semiconductor nanocrystals. If you are interested doing science and even going into inventions, I think this is a good place for you to be. Please feel free to reach us out if you'd like to be a scientist, a researcher, and an inventor at the same time. Thank you.
In our research group, we work on nanophotonic devices. We control the electronic and material properties in micro and nanoscale to develop chip-scale light sources, such as LEDs and lasers. Our goal is to develop photonic devices for applications in material processing, sensors, LiDARs, and quantum optics.
My name is Engin Durgun. I am working in the field of computational material science. With my research group, we are trying to discover new functional nanomaterials by using high-performance computers. In this way, we are aiming to model novel systems that can be used in a variety of nanotechnology applications. The interdisciplinary, motivating and supportive environment of UNAM takes our research efforts much further.
Hi, this is Hasan Yılmaz at Bilkent University, National Nanotechnology Research Center. Our group, which is Emerging Complex Optical Systems, works on complex optical materials. We study how light behaves and propagates in complex optical systems such as biological tissue or paper. We both try to understand fundamental optical processes, and also by our understanding develop new methods such as imaging, deep tissue imaging or spectroscopy in these complex systems. Thanks to the research environment at National Nanotechnology Research Center, we continue our research with great curiosity and success.
Hi, I am Ibrahim Sarpkaya. I am the principal investigator of Quantum Photonics Laboratory at UNAM. I would like to give brief information about my research group. My research group mainly focuses on light-matter interaction in low-dimensional materials. What are those low-dimensional materials? For example, one-dimensional carbon nanotubes and semiconducting 2D materials. The overall goal of our research is to better understand and control the photophysics of light emitters on those low-dimensional materials with the aim of using them efficiently in optoelectronic and quantum photonic devices. Here at UNAM, we have high-tech nanofabrication as well as material characterization tools. So UNAM helps us to realize the cutting-edge research in our research group.
Hello, I am Mehmet Yılmaz. I work tirelessly with the purpose of contributing to the Turkish advanced technology-focused manufacturing industry for mass production of MEMS sensors and MEMS actuators and educating part of the young generation of human power. Working together with the young generation of human power in my research and development group, starting from the idea stage, we use the advanced technology tools in Bilkent University UNAM's labs in order to manufacture these MEMS devices as adaptable to industrial scale mass production. On behalf of my research and development team, I am grateful to Bilkent University UNAM for giving us the opportunity to do our work.
Hi, my name is Mustafa Ordu. At UNAM, we are developing novel optical fibers for infrared light transmission. Our research interest covers semiconductor optical fibers, hollow core photonic crystal fibers, and microstructured polymer optical fibers. In our laboratory, that is Contemporary Fibers Lab, we model, fabricate, and characterize all these optical fibers. Also, we investigate the structural properties of glass fibers as a composite material. With UNAM's unique fiber fabrication and characterization facilities, we continuously work on our fibers and our dreams.
Hello, my name is Seymur Jahangirov. At UNAM, we are doing research in a wide range of topics. We are doing research in condensed matter physics, in complex systems, and in computational neuroscience. The common theme that unites these topics is doing exploration in computational universe. In this respect, we can understand the materials that do exist in nature, but we can also design new materials that do not exist in nature. Also, similarly, we can learn from the brain how it works and apply what we have learned to design artificial intelligence systems. We can do all this with a great success thanks to UNAM's interdisciplinary and transdisciplinary structure. Thank you very much.